And welcome back, guys. I haven't posted a video in a long time, actually, but today I want to cover hotcakes, hot takes.
That's not a good start, but keep going.
Why am I here today with this video? Initially, back in February, I was shared a post, which you see here on the screen, by our engineering team. It's rather aggressive post. And I would like to test this to see if it's true. Got to testing, and last month, before I ever posted anything, the same person posted a very similar post, called this claim 1.5, if you will. So it's basically the same exact post, but it's a slightly different one. And this one, at first, I thought he was talking about interactive. Nonetheless, I actually tested both serverless notebooks for this one and serverless jobs. So let's dive into this topic. Is Spark faster and cheaper to execute in Snowflake than it is on Databricks? So I began testing in February and ended up having some issues with some of the tests after a week or two into testing, delayed some of the publications I wanted to make. And the next thing you know, it's May, and we actually see the second claim come through. So these two claims are essentially the same claim, just with a slightly different take, slightly different code. They're both working on the TPCH data. He posts the same scale factor results for both. They're both very small scale factors. So what I wanted to do was to show the results that we got from both claims, both versions of code, what it looks like, and what's the performance for each of these under various different scenarios. The claim here talks about TPCH. It is only the data set that comes from TPCH, okay? And the way the TPCH works, or any other TPC benchmark, is they do this thing called scale factors. What does it mean to be a TPCH scale factor 100? TPCH scale factor 100 is still kind of small data. Once you actually put it into tables, it's roughly around 21 gigabytes, okay? It's basically the size. I could easily fit it inside of my MacBook memory, for example. So it's not a very big data set. What I wanted to do was make sure we're much more robust in our testing. So we tested on multiple different warehouse sizes. We're testing it on different scale factors. Most customers and for most workloads, you'll be working as bigger than 21 gigabytes of data, basically. One thing that Snowflake does is they pride themselves on how performant their warehouses are, right? They think that they have the most performant and the best engine out there. So whenever they want to make a comparison, they won't talk about the price of a warehouse or compare to another warehouse or platform based upon how much that warehouse is per hour. What they'll do is they'll compare against the actual compute size. So call me old fashioned, but in my opinion, and I think most customers would agree, but the more important factor is always going to be the price you're paying for performance. If you can give 10x the performance and choose to allocate 10x less resources because you're that much more efficient, then by all means do so. And I think that's what Snowflake's typical sentiment is. They feel like they're the fastest engine, so we'll offer less resources because we're that much faster and that much more efficient. Of course, when you feel like you have the more premium product, then when you make comparisons, of course, you will try to match up only aligned against the amount of compute resources and not aligned against the actual cost per hour. While Databricks serverless notebooks and jobs are dynamic in nature, so I can't show you a chart like this because nothing is fixed in those type of clusters. But what I can tell you is the comparable non-serverless cluster that you would get in Databricks. And these are the types of clusters he also still compared in both of his claims. How many workers, how much compute can you get for a similarly priced Snowflake warehouse? And these range anywhere from 2 to 3 times as many resources, depending on whether you're looking at the smaller end or the higher end here. Even though you're only getting 2 workers here compared to the extra small warehouse, it's still 21% more than those 2 workers in Snowflake to get that extra small. So it's still a higher than 2 to 1 ratio. It's usually around that 2.5 to 1 at the small end. And for those clamoring about a discussion on serverless, trust me, the serverless conversation will come soon. What we're trying to do is just establish a baseline about what's actually a comparable size or comparable priced warehouse between Databricks and Snowflake. It's a little bit disingenuous to compare Databricks to Snowflake based upon just compute size because Snowflake is charging more for each level of compute. You know what? What am I talking about? Screw it. Let's do a like for like test. Okay. Let's line up the exact same compute resources in Snowflake warehouses, and let's line up the exact same amount of compute resources in the Databricks cluster. Let's do the system under test, and let's figure out which of these platforms is the fastest to execute the code that he wrote in his notebooks for both claims. So what we could do is take the portion of code where he has a start time and the portion of code he has an end time. Everything in between these portions of code is the system under test. What we'll do is we'll have each platform race to see how fast they can execute the bulk portion of the code where all of the actual logic and work is being done for the analytics workload. Okay, enough talking. Let's get to some numbers. So after indulging the like for like comparison, you see here that Databricks is actually faster at every single scale factor and every single size. It's a clean sweep. Anything from 80% all the way up to 133% at 64 cores when you're comparing 64 core cluster to a large warehouse. I can already hear some of you saying that he actually tested a medium at that 100 scale factor. And sure, you can oversize the warehouse. I don't believe that you need that big of a warehouse at this scale factor, but you know what? Let's actually indulge it. Let's take a look and see exactly how that compares as well. So with a medium warehouse, you can actually get this to be about 12% faster than Databricks whenever it's running double the amount of cores. So throwing double the amount of resources barely clears the same bar that Databricks does with half as many cores. In fact, at the two larger scale factors here, you can see that even when Snowflake has double the amount of resources as the Databricks cluster, it still cannot hit the same performance level that Databricks does. Snowflake prices itself as the premium experience, as the platform that will give you the better performance. But as you can see here, it's actually the exact opposite. It's the Databricks performance that exceeds Snowflake. And in fact, in some cases exceeds Snowflake's performance even whenever Snowflake has doubled the amount of compute. And as you can see on this chart, we are seeing anywhere from 5 to 6.3 times higher cost for Snowflake for the same workload. Moving on to Claim 2 performance was actually a little bit closer. There's still a gap here. And so the heavier notebook still tells essentially the same story. You may notice that the scale factor of 100 and 1000 are the same size as Claim 1, but for 3000 and 10,000, we did increase it by one t-shirt size just because Claim 2 had a little bit more of a complicated or time-consuming set of queries that it needed to get through. But as you can see, 27% slower, up to 61% slower, depending on which scale factor you're looking at. It's a bit repetitive, but just like we had in Claim 1, Claim 2 performance reflects a TCO gap that's anywhere from about 3.5 to about 4.5 times the TCO that you would have in Databricks. So why is this test important? For a long time, Snowflake has marketed itself as a premium performance engine. It's why they charge so much for their product. It's why they have such a higher margin for their product. However, in this test, we've shown that isn't true, right? So all you're left with is a platform engine that you price as if it's best in class by a wide margin, but doesn't deliver that level of performance. So every platform can choose to price their product based upon the value, performance, and experience that it offers. And if Snowflake could provide that 3x performance for each compute resource that it allocates than its competitors can, then sure, by all means, they should be able to charge 3 times more for it. If I ran an oil company and the R&D department created a gasoline that's 3 times more efficient and offers 3 times more miles per gallon than any other competitive gasoline out there, I'm well within my right to charge 3 times for that gas. The end result is actually the opposite. It's Databricks that is outperforming Snowflake, and in some cases, with half the size cluster as the size of the Snowflake warehouse. On average, Snowflake is 72% slower than the Databricks cluster of the same size compute. And in many ways, this actually helps contextualize some of the following conversation. It's why this test is actually extremely important. If you're lining up the exact same amount of resources and just asking how long does it take to get through the actual work that needs to be done in the code, it's Databricks that actually outperforms Snowflake. And I know that there are many watching this video clamoring that, Snowflake has a serverless experience. This is not a fair test. Snowflake has serverless. Databricks didn't use serverless here. And that's why you're paying a premium price for that Snowflake offering. To counter that, I'd say that Databricks also has serverless, and often it's actually something overlooked in many Snowflake tests, but we will make sure that we get that addressed in the performance test today. Before we close the book on this performance engine test, let's actually take a look at that question that gets begged about the serverless experience. So here on the screen, I'm actually running the same notebook that we were just testing. This is using Workspace notebooks, which replaced the legacy notebooks in Snowflake in March. Workspace notebooks require a second compute plane through SPCS, which is Snowpark Container Services. This compute plane is what executes the Python and REPL and has a 24-hour auto idle termination time. The warehouse can still have that default 5-minute timeout execution, but acts as a second compute plane for your notebooks. So what we'll do is we'll let this notebook spin up and execute while we wait for the compute to come up.
You get the idea.
After a minute, 12 seconds, The compute is up. Now it's ready to install the libraries. Library installation can also take a while as well, but while we're doing this, let's actually start up the Databricks version and show you what it looks like in Databricks to spin up serverless. Here I'm using serverless notebooks to better demonstrate that startup. Performance optimized serverless jobs spins up resources in the same amount of time as serverless notebooks do. Despite the fact that we started this well over a minute after the Snowflake attempt to start compute and get this notebook running, Databricks is already finished. It took less than 20 seconds to get the serverless compute started and to install the libraries. Meanwhile, that is still significantly faster than just the amount of time it takes to install libraries, let alone the over 1 minute to spin up compute. So is the serverless experience better in Databricks for notebooks, or is it better in Snowflake? I'll leave that for you to decide. I'm just the messenger. Okay, I'm switching the Databricks job back over to a classic one so we can have an apples to apples comparison. I only just showed the last video as a comparison for serverless experiences. We were already discussing it, but we'll speed this up to 8x speed so we can get this done quickly and then see the actual performance difference in the system under test as well. So not only does Databricks have the better serverless experience for notebooks, it is also the faster engine. Okay, engine test out of the way. Again, I think most of you are probably, if you're a Snowflake fan, screaming that, hey, look, Snowflake has serverless. You tested this with Classic. It's not a fair comparison. And I agree. The intent of the last test was just to test on which engine's faster. Hey, both are up and running. They both get to work to be done. Which one got through the work faster with the exact same amount of resources? And that was Databricks. But you're right, serverless, it brings a better user experience. And luckily, Databricks also has serverless offerings. We've established that Databricks has the most compute allocated for every dollar spent and also has the fastest engine. So one thing performance optimized serverless does is it optimizes your workloads for total cost of ownership and for performance. It allocates the exact amount of resources that are needed based upon the demand of your job. It also meant we only had one variation to test in Databricks. There's only one choice selected in the following test results, and that is performance optimized serverless. In Snowflake, we had a significant number of variations we had to test, which actually in Snowflake, we had to test over 20 different variations, and that actually just led to complexity that we didn't foresee. That complexity also does run counter to how they go to market and their public perception. It's certainly a far different cry from their marketing pitch. Hi. So now we have to get into something that's very confusing and also very boring called legacy notebooks or workspace notebooks. So what I'm going to do is play a game that I like to now call speed read through all the boring portion. Legacy notebooks, or just notebooks when the poster and I tested this initially, still exist, but got the legacy designation after Snowflake's new workspace notebooks were released. Legacy notebooks carry a default 30-minute idle timeout, minimum 15 minutes, but also allowed you to be able to select the same warehouse for both the compute and the warehouse, meaning you do not have to pay double compute charges for a separate warehouse or Snowflake container service. However, workspace notebooks allow no such flexibility, requiring a separate minimum service on top of the warehouse. Therefore, workspace notebooks require two separate compute planes to be spun up. A warehouse that carries a 5-minute default auto stop, a non-scalable dedicated compute service that carries a 24-hour idle timeout, or idle auto stop or ramp down portion. This compute is only available to a single user. It cannot be shared among other users in the workspace. Calculating Snowflake's TCO as fairly as possible is important. Idle auto stop and ramp down costs can't simply be removed, though. Databricks serverless jobs costs already include all startup and ramp down, so zeroing them out for Snowflake would be an unfair comparison. The goal is the lowest reasonable attribution for Snowflake, not zero. Snowflake's own defaults are higher than what I use in these charts. Notebook auto stop and warehouse defaults 30 minutes. I use the 15-minute minimum. General warehouse auto stop defaults to 5 minutes. I use the 1 minute minimum. For each run, I take the cheaper of the two valid ramp down paths. Warehouse only, you must accept the 15-minute warehouse auto stop. Snowpark container service allows for lower warehouse auto stop, but the service itself carries a 24-hour auto stop, which is cheaper per hour, but a far longer duration. Whichever path produces the lower cost, each scale factor is the one I used here in the Snowflake charts, consistently giving Snowflake the benefit of the doubt. Databricks is already winning by such a sizable margin, and I'm trying to leave very little reason for viewers to doubt these results. However, what I can't do is remove a ramp down completely. All serverless platforms include them in their pricing models, but have different ways of applying them. Databricks costs already have them baked in, while Snowflake forces the idle times.
Boy, that escalated quickly. I mean, that really got out of hand fast.
Thank you for your patience. So without more delay, let's take a look and see what the charts show on performance tests for performance optimized serverless jobs and for Snowflake's Gen 2 warehouses. So let's evaluate the first claim using serverless jobs. Databricks performance optimized serverless jobs are faster and cheaper than Snowflake Gen 2 warehouses at every single one of the scales. One interesting thing of note here is the inverted bell curve on the right, while we have a bell curve on the left, which seems to indicate that there is a relationship with performance and TCO across these fixed warehouse sizes. Notice we also tested very small scales and very large scales, everything from scale factor 100 all the way to scale factor 30,000. I even ran a test using Snowflake's adaptive warehouses. And as one would expect, if you increase the size of the warehouse, notice here that we went one size larger at each one of these scale factors than the previous test. You actually can get the performance to outpace Databricks serverless jobs, but mainly because you're oversizing the warehouses again. Notice the prices on all of these have actually gone up to be even higher than they were in the last one. And what we're seeing here is that even if you are oversizing it, as soon as you get to the 1000 scale factor, Databricks serverless jobs still outpaces every single one of these. Moving over to the second claim, this is a test where, again, we're trying to focus on the Snowflake warehouse that still delivers the best TCO. So you'll notice here the small warehouse is still here for the scale factor 100, but everything from scale factor 1000, 3000, and 10,000 has an increased warehouse size, mainly because the second claim actually had code that took a little bit longer and required a little bit more work to get done. So we wanted to optimize and make sure we're still delivering here results that show you the Snowflake best TCO at every single layer. On the right side, you'll notice that total cost is actually rather consistent to Databricks, between 1.9 and 2.1 across the board. So this test was by far the closest in terms of TCO with Databricks. And the final chart I'll show you here is actually originally, when this was posted, I thought this was tested against interactive. So I wanted to make sure that we had a serverless notebooks test against this. So this chart is actually showing serverless notebooks against the scale factor 100, 1000, and 3000, where we actually increased the size of the warehouse on the Snowflake side to a large on a scale factor 100, which actually is something he alluded to in the original post that he ran this on an adaptive large. So I wanted to see how serverless notebooks compare to that same escalation, if you will, on the warehouse size for such a small scale factor, and they basically broke even. So serverless notebooks is about equal in terms of the adaptive warehouse for a Snowflake large, even at the small scale factor, and then is actually faster or break even at the 1000 and 3000, even when you go up to an extra large or a 2XL on those. And as you can see on the right, total cost, it looks like it's a little bit more narrow than you would expect based upon the performance and the sizes of these warehouses. But at the same time, this is also serverless notebooks, which do carry a slightly higher total cost of ownership than serverless jobs do. But nonetheless, it matches performance or beats performance in every case, and it beats the TCO in all cases. Before we move on from these claims, I want to close this out with talking about some of the issues I had in February. So the reason why nothing got published in February was because I came down to publishing, had all my tests ready. I'd run this for about a week, gotten all the tests I needed, and I was ready to publish. But then as I was collecting, I think a video at the time to try to, hey, am I going to do a video or am I doing a blog? I was trying to record a video to document how long it was taking for Snowflake. And then the same jobs that had been running previously just fine started to fall off a cliff. And this went on for about a week. I met with various Snowflake SMEs. I even met with James Malone and some others, right, who, formerly from Snowflake. And I was like, hey, guys, I haven't changed these jobs. I haven't changed anything in the warehouses. And I can't tell why all of a sudden, small scale factors are going from like, 3.5 minutes maybe to over 10 minutes. I can't tell why, a scale factor 1000 is going from 8 minutes all the way up to 74 minutes. And I can't tell why I can't even get a 3000, 10,000, these other large scale factors to actually finish it all. Okay. These are jobs that would run for over 16 hours before I just killed them. Okay. And I'm not sure how many of you know how much running a 2XL or a 3XL warehouse in Snowflake is when you have to run it for 16 hours and they don't finish. Okay. The most money that was spent in the last 3 months of testing for this was spent on jobs that did not even finish in Snowflake, jobs that ran for 12, 14, 16, 18 hours. Okay. And I couldn't get them to finish before I had to basically kill the job. And I didn't know why. So I didn't know if the performance was ever going to come back. I didn't know if I was doing something wrong, but eventually it just solved itself. So about a week after it began, performance went back to normal. Okay. Now, I tried researching this to find out why I was facing so many issues. And so I pulled up to see if there were any like, patch fixes that had occurred or, anything published by Snowflake that, hey, we run into an issue. This has been resolved now, but I couldn't find anything. So I went to AI to try to figure out like, hey, why am I getting this result? So I'm going to summarize here what we got from the AI tool about what it thinks is happening, right? So the deep learning analysis shows that Snowflake does not always plan the code execution the same across runs. So despite no changes in the notebook or the warehouse or any other configuration changes, basically the performance can just fall off a cliff. So doing the deeper analysis, I was able to narrow down when there will be a poor result because I could see that the plan appeared to be suboptimal. And so I don't know why this would happen or what the system was doing when it generated these poor plans, only that I see a differently planned notebook when the notebook execution performed poorly. So I don't know why it's happening. There's no code changes, but I can see the query plan itself, the queries that get sent to the warehouse are almost identical in most cases, but there's some extra queries in there. Okay. I only had one poorly planned query finish at the 3,000 scale factor higher, which is that the one at the 3,000, which I just showed in the chart. Okay. After running for many hours, I basically killed the execution. Okay. And you could see from the query history screenshot below, I had 9 notebook execution attempts that ran for over an hour. And as you can see here, there's plenty that actually ran for 2, 4, up to 16 hours here. In fact, there's 4 here that ran for over 14 hours. And as you can see, never even finished.
60% of the time, it works every time.
But taking a deeper look at the poor runs, the query history that you see here shows that the 2 notebook execution attempts on the same warehouse at the 100 scale factor, and they're queried by the session ID, so you can only see the queries executed by the notebook in that attempt. The poor runs on the left, the good runs on the right. And you'll notice that it says 62 queries to 47 queries. There's really 2 separate sets of 7 extra queries. I've got 7 queries highlighted here on the screen. As you can see, these are the added queries. The higher the number here actually represents the older query. So these are the queries near the beginning after some of the setup steps happen. Now, these actually don't take much time. They're all actually very fast, less than a second. So these queries, even though they finish very quickly, they are essentially the indicator for the rest of the queries taking the wrong path or taking the wrong pattern. The screenshot that you see on the screen now show the bad run on the left and the good run on the right again. But what you see on the left is the same exact queries. Every one of these queries have the exact same text in them. We pulled every single query, and they are actually sending the exact same query to the warehouses. But you'll notice that even at the 100 scale factor, some of these queries are running extremely long. A 5-second query becomes a 1-minute 13-second query. A 37-second query becomes a 3-minute 46-second query. Whereas the rest of these are all pretty straightforward. My theory is that what's happening is that the Snowpark planner, the tool that actually turns the Python code into SQL code, thinks that the code is actually supposed to be staying in Python and pandas and stays in the REPL, but never actually sends any of the queries through the warehouse. It's since been resolved. And so all the results I've talked about so far are only the good run results, or they're only the positive results. But what this meant is that I lost a week in the testing, and then I spent more time after that trying to figure out was the good state the good real state, or was the bad state the real state. So I spent a lot of time trying to figure out what the heck happened here because I was ready to publish. Now I have 2 different types of results here. I would hope that this is all resolved for Snowflake now. Things are back to normal, but this is not ideal if you're a customer and seeing that, hey, sometimes for some reason this turns into a complete. So my semi-professional video editing skills have not gotten any better. They're currently only second to my semi-professional hopscotch skills. But what I can tell you is that we are now in San Francisco for Data and AI Summit. So I'm wrapping up my conclusion here after I've done all of my editing here on the plane today. So what did we learn in this video? So the first obvious thing we've learned is that Snowpark in Snowflake is not a more effective Spark executor on this code, at least. I mean, perhaps there's another piece of code that actually does run better in Snowpark, but it certainly wasn't the one that he shared in his repo. Second thing is the serverless experience. In my opinion, again, everybody can have their own take on this. You can provide your take in the comments, but from what I saw and in my experience, the serverless experience in Databricks is a much more superior product. In addition, the serverless performance in TCO is easily the better offering in Databricks as well at pretty much every scale factor. So what we've learned today is that basically I think we could call this claim debunked, and look forward to catching up with as many of you as possible while I'm here in San Francisco at Data and AI Summit. Cheers.